Slide 3 shows an example of having direct effects from covariates to latent class indicators. In this case, we're taking a look at 6 binary indicators, U1 through U6, measuring a latent class variable C, where we have covariates x1 through x3 and distal outcomes y1 through y3. And we have 2 direct effects, one from x1 to u2 and one from x3 to u5. So there are direct effects. They do not go via C, but they go directly from x to u. So a direct effect implies that for a given class conditional on C, the probability of u is not the same for different values of x. So different individuals having different x values will have different probability of u, even conditional on class. So that means that the measurement model parameters are not the same for different individuals, and that's referred to as measurement non-invariance or differential item functioning, diff, in the item response theory context. And it's also referred to as item bias. For example, with a binary X describing 2 groups, say males, females, the measurement instrument does not work the same for the 2 groups. Slide 4 then, I go through the analysis impact of ignoring direct effects. Consequences of ignoring direct effects. First one is the violation of conditional independence given C. So now class enumeration, that is deciding on the number of classes, I'm claiming that the impact is likely small. And think about this example. Say that you have found 3 classes, or say that rather that there are 3 classes as the true state of affairs, but you have these direct effects, which means that U2 and U5 will correlate even given class because they're influenced by x1 and x3 that correlate. So you have this residual correlation between latent class indicators, which might lead you to choose 4 classes instead of the correct 3 classes. But the impact probably is typically not large. You may not often find more classes, a need for more classes. Now you also have distorted model estimates in terms of class probabilities, typically small impact with or without using the x variables. So you have an analysis, say, with only the latent class indicators, no x's, but there are direct effects, and therefore correlation between U2 and U5 beyond that of C, that generated by C. So that I'm claiming is small, and even if you include the x's, it's also probably a fairly small distortion. However, C on x, the regression of C on the covariates, I claim has a large impact of ignoring direct effects, because the direct effects are forced to go through only C. So x1, which influences C and therefore indirectly U2, also has a direct effect, and when you don't allow that, x1's influence on C is likely to be increased to capture the correlation between x1 and u2. And we described that in a paper, 2014 paper in the SEM journal, which is largely the same as WebNote 15 on the Mplus website. Now y on x then, this part, the y's regressed on x, I would claim that there is some impact, because when C on x change, this C on x part here changes, the indirect effects of x on y via C will change because of the change here. And therefore there will be a change in y on x. So if the indirect effect via C changes, y is influenced by C but also by the x's, then the influence of x onto y directly, not via C, changes to some extent. And we'll see an example of that towards the end of this talk. I'm also going to cover multi-step analysis, where in this example it would be focusing on the distal outcomes Y here in the last step of the analysis. And the first step analysis then, which is usually the measurement model as we discussed in Webtalk 8. It's the measurement model, but in this case we're going to let the measurement model include the X part, include the covariates and its direct effects onto the latent class indicators. And then in the last step, add the distal outcomes. So turning to the outline on slide 5, we're now going to present an example that we're going to use throughout, antisocial behavior example that we also used in Webtalk 8. So here's the data set on slide 6. We have 17 antisocial behavior items, which constitute the binary latent class indicators, because we dichotomized the frequency of various behaviors during the past year. And we have a little over 7,000 respondents, and there's no missing data in this data set. I have analyzed these data before in structural equation modeling, mimic four-factor analysis in this paper for the Cambridge University Handbook. You have the reference at the end of the talk. And also when it comes to latent class analysis in Mplus short course topic 5, where I look at both 4 and 5 class LCA for these 17 latent class indicators. And with 5 classes being high on all the indicators, property offense indicators endorsed only, drug, person offense, and a low normative class. In this talk I'm going to work with 4 classes. Now ASB, antisocial behavior data, that's a general population survey of young people, so that considerable heterogeneity among these individuals can be expected, which would mean that we should be able to see a lot of direct effects being significant. In this talk I'm going to work with 2 versions of the data set. One version, the full version, I work with the 17 binary U indicators and 11 covariates. And I'm also going to work with the reduced set, where you only have 7 indicators and 7 covariates, and where you're going to work with 2 distal outcomes. On slide 7, we see the input for the analysis of the full set with 17 latent class indicators and 11 covariates. And in this case, we bring in the regression of the latent class variable C on the axis, but we have no direct effects yet. So we have the ASB data set here, and the use variables are the 17 indicators, property through gambling, and then we have the 11 covariates, sex through abuse. And we declare the indicators as categorical. They are binary in this case, dichotomized. And we ask for 4 classes. We have mixture modeling using ML and a good number of random starting values. And I use 12 processors to speed that up. And in the model then, in the overall part, we have C on all of these 11 covariates. And as usual, the latent class indicator thresholds or probabilities vary across the classes as the default, so we don't have to mention them. So with 17 U's and 11 X's, we have 17 times 11 equals 187 possible direct effects. So now we have to try to figure out which ones are important to include.